Chapter 12 of The Hurricane Hunters by Ivan Ray Tannehill. This LibriVox recording is in the public domain. Chapter 12, Trailing the Terrible Typhoon. The Workshop of Nature in Her Wildest Mood. Tepperman. So far as anyone knows, the most furious of the typhoons of the Pacific are no bigger or more violent than the worst of the huge hurricanes of the Atlantic and the West Indies. They belong to the same death-dealing breed of storms, but the typhoons come from the bigger ocean. They sweep majestically across these vast waters toward the world's largest continent, and to the south and southeast lies a longer stretch of hot tropical seas than anywhere else on earth. Perhaps it is the enormous extent of the environment that explains the fact that in the average year there are 3 or 4 times as many Pacific typhoons as there are West Indian hurricanes. The greater excess of energy generated in this enormous Pacific storm region by hot sun on slow-moving waters is evidently released by a more frequent rather than a more violent dissolution of the stability of the atmosphere. But there is something about typhoons that causes the people to look upon them with even greater terror than in the case of hurricanes. Likewise, the storm hunters tackle the job of tackling them with less confidence. Typhoons come from greater distances. Their points of origin may be scattered over a wider area. Much more often than is the case with hurricanes, there may be 2 or more at the same time. In their paths of devastation, they fan out over a bigger and more populous part of the world. It takes more planes, more men, and longer flights to keep up with typhoons than with hurricanes. For many decades, the people of the Far East struggled valiantly against the typhoon menace without much interest on the part of the Western world. Native observers reported them when they showed their first dangerous signs, and then came roaring by the islands in the Pacific, including the Philippines, as they swept a path of devastation on the way to China or Japan. Men on ships equipped with radio sent frantic weather messages to Manila, Shanghai, or Tokyo as they were being battered by monstrous winds and seas. Father Charles Depperman, S.J., formerly of the Philippine Weather Bureau, who did as much as any man to help people prepare for these catastrophes, made an investigation to see why some of the typhoon reports from native observers were defective. He listed a few of the reasons. One observer said his house was shaking so much in the storm that he was unable to finish the observation. He added that 90% of the houses around him were thrown to the ground. Another common complaint was that the observers could not read the thermometers because the air was full of flying tin and wood. Another apologetic man put on the end of his observation a note that the roof of the weather station was off and the sea was coming in. The observer on the island of Yap fled to the Catholic rectory and looked back to see his roof, walls, and doors blowing away, but he sent his record to the forecast office. Another observer on Yap was reading the barometer when it was hit by a flying piece of wood, and the observer was knocked to the floor. One of the observers had excuses for a poor observation because he had to run against the wind in water knee-deep. In another place, the wind blew 2 rooms off the observer's house at observation time. But the most convincing excuse for failure was from another town where the observer was drowned in a typhoon before the record was finished. It is a strange fact, too, that one can look at all these records and the reports written by the Pacific storm hunters after they got going, and seldom see a vivid description of the fearful conditions in the typhoon. The white clouds turning grayish and then copper-colored or red at sunset. The rain squalls carried furiously along. The roar of giant winds and the booming sea as the typhoon takes possession of its empire in huge spirals of destruction. With death and ruin on all sides, nobody seemed to have the energy to write about it. The tumult passed, the wind subsided, the water went out slowly, and the observer wrote a brief apology for the bedraggled condition of the records. In the same way, the typhoon hunters let their planes down at home base, too tired to do anything except compile a few technical notes. The vastness of the thing seemed to leave them speechless. The plane went out on a mission, and the base soon vanished, a shrinking dot on the horizon. The mind, tired of thinking about the near infinite expanse of Pacific waters, of thinking about running out of fuel in an endless search of winds, clouds, and waves, of thinking about never getting back to that little dot beyond the horizon. Into this ominous arena the American fleet nosed its way, island by island, in the war against the Japanese. By methods which had been handed down from older generations, strengthened by all the modern improvements that could be added, the Americans tried to keep track of tropical storms in this enormous region where trade winds, monsoons, and tropical winds hold their several courses across seemingly endless seas, but here and there run into conflict or converge in chaos. Twice, when their predictions were not very good, the fleet suffered, and in the second instance the typhoon humbled the greatest fleet that ever was assembled on the high seas. The Commander-in-Chief Pacific demanded reconnaissance without delay. As men do in time of war, the Navy aerologist moved swiftly and effectively to meet the challenge. In fact, they had anticipated it in part, and had plans in the blueprint stage, even before the big Third Fleet took its brutal beating in December 1944. Most of the stimulus came from the Atlantic side, where organized hurricane hunting had begun in the middle of the year. But it was not long until the Japanese were driven out of the typhoon areas. In June 1945, they were being blasted out of Okinawa as typhoon reconnaissance was beginning. In fact, the first men to go out to penetrate a typhoon had to be careful to keep away from Okinawa. By that time, the Japanese had committed all their fading sea and air power, including their vast remaining battleship, to the defense of Okinawa, and after June, the U.S. Navy had no real enemy except the typhoon. Beginning in June 1945, the Navy airmen and aerologists flew two kinds of missions. Almost daily they went out to check the weather, and if they found a full-grown typhoon, or one in formation in an advanced stage, special recos were sent out. One flight went out as soon as it was daylight, and the second took off about 6 hours afterward, early enough to make sure that the second would be completed by nightfall. This was rather tough going. As one of the aerologists pointed out, Pacific distances were so large that if they were considered in terms of similar distances in the United States, a common mission would be like a takeoff from Memphis and a search of the area of a triangle extending from Washington, D.C. to New York City and back to Memphis. Aircraft used by the Navy were Catalinas, PBYs, Liberators, PBY-1s, and Privateers, PB-4Y-2s. All were four-engined, land-based bombers, some fitted with extra gasoline tanks for long ranges. Before leaving base in the Philippines or the Marianas, the aerologist briefed the crews. In flight, the aerologist directed changes in the course of the plane, but the pilot could use his own judgment at any time when he thought the change might exceed operational safety. From June through September 1945, the Navy flew a total of 100 typhoon missions, averaging 10 hours each. Lieutenant Paul A. Humphrey, a Weather Bureau scientist after the war, and Robert C. Fite, both of whom flew constantly on these missions, gathered data from all flight crews, and at the end of the season wrote descriptions of 5 typhoons which were more or less typical. Some of the most interesting of these missions were directed into the big typhoon which came from the east, crossed Luzon on the Philippines, and roared into the China Sea in the early part of August. On the 4th of the month, one of the Catalinas was checking the weather 300 miles east of Leyte and saw a low-pressure system developing a small tropical disturbance. It grew, was checked daily, and on the 6th blew across Luzon and reached its greatest fury in the South China Sea on the 7th. The first plane that went into the typhoon in this position was directed to the right and north of the center to take advantage of tailwinds and to spiral gradually into the center. As it approached the center, the plane climbed to about 5,000 feet, and the crew had a beautiful panoramic view of the clouds piled up on the outer rim of the eye. On account of the awful severity of the turbulence the plane had experienced around the eye, they descended again and flew to home base at altitudes between 200 and 300 feet. On examination of the aircraft after the battered crew had let down at home base, it was found that the control cables were permanently loosened, the skin on the bottom of the port elevator fin had been cracked away from the fuselage, one plexiglass window was bowed inward, and the paint was removed from the leading edges. Because of the violence of turbulence on this flight, the nervous crew of the second Recco plane on that day was instructed to reconnoiter but not to try to go into the center. On the 5th of September, a violent typhoon formed between the Philippines and Palau and moved northwestward toward Formosa. On the 10th, a Recco plane ran into trouble in this storm. Twice while flying at 2,000 feet, it met severe downdrafts, losing altitude at 500 to 1,000 feet per minute, while nosed upward and climbing at full power. The eddy turbulence was extremely severe, and most of the crew members became sick. The second Recco plane on that date ran into violent turbulence also, and at times it was almost impossible for the pilot and co-pilot to keep the plane under control. And then disaster struck. By the end of September, the Navy storm hunters had gone out on 100 missions into the hearts of typhoons, and although many of them had been frightened and badly battered, there had been no casualties. They made up a report as of September 30, commenting on their phenomenal good fortune on these many flights. But on the very next day, October 1st, one of the crews which had been making these perilous missions departed on a flight into a typhoon over the China Sea. Those men never came back. No one had any idea as to what had actually happened, but the members of other crews could well imagine what might have happened, and whatever it was, it must have ended in typhoon-swept waters, where none of the storm hunters expected to have any chance of survival. It could have happened in the powerful winds around the eye, or in one of those bands extending spirally outward from the center, filled with tremendous squalls and fraught with danger to brave men venturing into these monstrous cyclones of the Pacific. The report, even before this sequel, had stressed the hazardous nature of reconnaissance. In these Pacific missions, the pilots and aerologists, often without radar, had become aware of the donut-shaped body of the storm with squall bands spiraling outward, the octopus arms. But they got very little information that they thought would help in predicting the movements of typhoons, except the old rule that the storm is likely to continue on its course unchanged, tending to follow the average path for the season. The explorations by aircraft as a means of getting data were far more useful in locating storms and determining their tracks, however, than any other methods. After the end of 1945, the reconnaissance of tropical storms, both in the Atlantic and the Pacific, was in trouble, owing to demobilization. Many experienced men returned to civil life, and it was necessary to start training all over again. The Navy set up schools for 2 squadrons of Pacific storm hunters late in 1945 at Camp Kearney in California. The graduates were in action in 1946. After the surrender of the Japanese, the Air Corps maintained a weather wing in the Pacific with headquarters in Tokyo. Part of its job was to give warnings of typhoons threatening Okinawa, where the United States had established a big military base. Here they thought they had built structures strong enough to withstand typhoons, but they learned some bitter lessons. The most violent of all the typhoons of this period was one named Gloria, which almost wiped Okinawa clean in July 1949. A most unusual incident occurred over the island of Okinawa when the center of Gloria was passing. The Air Force was short of planes in safe condition for Recco, but managed to get enough data to indicate the force and probable arrival of this violent typhoon. It happened that Captain Roy Ladd, commander of Flight Number 3, was in the area, with Colonel Thomas Moorman on board, making an inspection of Reco procedures in the area. Their report gave the following information. As Gloria roared over a helpless and prostrate Okinawa, weather reconnaissance members of Crew B-1 circled in the eye of the big blow and watched the destruction of the island while talking to another eyewitness on the ground. That hapless human was the duty operator for Okinawa Flight Control, who, despite the fact that his world was literally disappearing before his eyes and the roof ripping off overhead, nevertheless stuck to his post and eventually contacted 3 aircraft flying within the control zone and cleared them to other bases away from the storm's path. Describing the situation, Captain Ladd stated that he had attempted radio contact with Okinawa for some time, but was prevented from doing so by severe atmospheric conditions. After a connection had been established 100 miles out from Okinawa's east coast, the control operator requested them to contact 2 other aircraft in the area and advised them to communicate with Tokyo Control for further instructions. Shortly thereafter, the RB-29 broke through heavy cloud formations into the comparatively clear eye of the big typhoon. The southern tip of the island became visible just under the western edge of Gloria's core. Gigantic swells were breaking upon the coast, and the control operator advised that winds had been 105 miles per hour just 30 minutes before, and had been increasing rapidly. He reported that the control building's roof had just blown off, all types of debris were flying by, and aircraft were being tossed about like toys. A little later, the ground operator had to crawl under a table to get shelter because nearly all the building had been blown away, bit by bit. Structures of the Quonset type were crushed like matchboxes and carried away like pieces of paper. Their roofs were ripped like rags. A cook at the Air Force Base hurried into a large walk-in refrigerator when everything began to blow away. "It was the only safe place I could find," he explained afterward. "The building blew away, but the refrigerator was left behind, and here I am." One of the meanest of the typhoons of this period was known as Vulture Charlie. It was dangerous to airmen because of the extreme violence of its turbulence. Ordinarily, the typhoons were known by girls' names, and for that reason the typhoon hunters in the Pacific were known as girl chasers. But Vulture Charlie got the first word of its name from the type of mission involved, and Charlie from the 3rd word in the phonetic alphabet used in communications. On November 4, 1948, an aircraft commanded by Captain Louis J. DeSandro ran into the violent turmoil of Vulture Charlie and described it as follows. "We hit heavy rain, and suddenly the airspeed and rate of climb began to increase alarmingly and reached a maximum of 260 miles per hour and 4,000 feet per minute climb to an altitude of 3,700 feet. The sudden increase in altitude was brought about by disengaging the elevator control of the autopilot and raising the nose to control the airspeed. Power was not reduced because of our low altitude. After about 30 seconds to 1 minute of this unusual condition, we hit a terrific bump, which appeared to be the result of breaking out of a thunderhead. The airspeed then decreased to 130 miles per hour in a few seconds due to the fact that we encountered downdrafts on the outer portion of the thunderhead and were momentarily suspended in air. At this point, the left wing dropped slightly, and I immediately shoved the nose down to regain airspeed. Before a safe airspeed was again reached, we had descended to an altitude of 1,100 feet. As a result of this turbulence, my feet came up off the rudder pedals. The engineer, who was sitting on the nose wheel door instructing a student engineer, came up off the floor like he was floating in the air. The navigator and weather observer were raised out of their seats. A coffee cup, which was on the back of the airplane commander's instrument panel, was raised to the ceiling and came down on the weather observer's table. Cabin airflow was being used, and the airflow meter exploded, and glass hit both engineers in the face. In December 1948, a crew under the command of Lieutenant David Likens was instructed to use the boxing procedure in a typhoon called Beverly. On one of their missions, they flew into it on December 7. The following is based on his report. The operations office instructed the crew to climb to the 700 millibar level, about 10,000 feet, after takeoff, penetrate the eye of the storm, take a fix in the center, then make a spiral descent and sounding down to 1,500 feet, and proceed out of the storm on a northwesterly heading to begin the pattern around the storm center. After the briefing, the crew ate dinner while talking anxiously about the trip, and returned to the aircraft to load personal equipment. When they were airborne with the gear and flaps up, they made an initial contact with Guam Control. There was no reported traffic, so they were cleared. The instructions were complied with, and a heading of 270 degrees was taken up. Soon there was discernible on the horizon a vast coverage of high, thin clouds at about 30,000 feet. This indicated the presence of the storm, verified by the south wind and slight swells that were perpendicular to the flight direction of the plane. The wind was increasing, and the swells were noticed to intensify. The boundary of the storm area was very distinct as they approached the edge. At this point, the surface wind was estimated to be 35 knots from 180 degrees. A few minutes later, they were on 100% instrument flying conditions, and the moderate to heavy rain and moderate turbulence persisted until they missed the eye and flew south for 15 minutes. Because they were on instruments and could not see the surface, they were unable to determine the highest wind velocity in the storm. It was estimated close to 100 knots. At this point, they noticed that they had a good drift correction for hitting the center satisfactorily, so they held the 270 degrees heading, relying on the radar observer to be able to see the eye on the scope. Approximately 15 or 20 minutes later, the radar observer reported seeing a semicircular ring of clouds about 25 degrees to the right, at about 25 miles range. The same kind of ring was detected to the left, about the same distance, however. Figuring they had drifted to the right of the center, they elected to intercept the left center seen on the radar, and flew until they received an ill-omened pressure rise, when it was apparent they had made a wrong choice. To make sure they were not chasing circular rings of heavy clouds, or false eyes on the scope, they made a turn to 180 degrees and held it long enough to enable them to see the surface wind. After about 10 minutes, they saw the surface and judged the wind to be coming from approximately west-northwest. They headed back for the center of the storm with the wind off their left wing, allowing 15 to 20 degrees for drift. In approximately 15 minutes, the radar observer reported the eye as being almost directly ahead. Lieutenant Likens said, "At 0906Z, 1906 Guam time, we broke out into the most beautiful and well-defined eye that I have ever seen. It was a perfect circle about 30 miles in diameter and beautifully clear overhead. The sides sloped gently inward toward the bottom from 25,000 feet and appeared to be formed by a solid cloud layer down to approximately 5,000 feet. From 1,000 feet to 5,000 feet were tiers of circular cumulus clouds giving the effect of seats in a huge stadium." They descended in the eye, made their observations, and then prepared to depart. Lieutenant Likens continued, "As we entered the edge of the eye, we were shaken by turbulence so severe that it took both pilots to keep the airplane in an upright attitude. At times, the updrafts and downdrafts were so severe that I was forced down in my seat so hard that I could not lift my head and I could not see the instruments. Other times I was thrown against my safety belt so hard that my arms and legs were of no use momentarily, and I was unable to exert pressure on the controls. All I could do was use the artificial horizon momentarily until I could see and interpret the rest of the instruments. These violent forces were not of long duration, fortunately, for had they been, it would have been physically impossible to control the airplane. Since the updrafts and downdrafts were so severe, we were unable to maintain control of the altitude. All we could do was to hold the airspeed within limits to keep the airplane from tearing up from too much speed or from stalling out from too little. After the first few seconds, we managed to have the third pilot, who was riding on the flight deck, advance the RPM to 2400 so we could use extra power in the downdrafts, and so we could start a gradual ascent from the area. Neither of us at the controls dared leave them long enough to do it ourselves. The third pilot received a lump on his forehead when he struck the rear of the pilot's seat, and bruised his shoulder from another source in doing so. Since he had no safety belt, he was thrown all over the flight deck. This area of severe turbulence lasted between 5 and 6 minutes, and every second during this time it was all both of us could do to keep the airplane in a safe attitude and to keep it within safe airspeed limits and maintain a general heading. It is almost impossible for me to describe accurately or to exaggerate the severity of the turbulence we encountered. To some it may sound exaggerated and utterly fantastic, but to me it was a fight for life. I have flown many weather missions in my 30 months in the 514th Reconnaissance Squadron. I have flown night combat missions in rough winter weather out of England, and I have instructed instrument flying in the States. But never have I even dreamed of such turbulence as we encountered in Typhoon Beverly. It is amazing to me that our ship held together as it did. When the severest turbulence subsided, the hurricane hunters found they had gained an altitude of about 6,000 feet. At this point, they decided to climb to 10,500 feet and proceed directly to Clark Field. It was night time, and since they were shaken up pretty badly, this seemed the most sensible course of action to be taken. They had no way of knowing the extent of any damage they might have sustained. The engineer reported that the booster pumps had all gone into high boost. One generator had quit. The radar observer said that the rear of the airplane was a mass of rubble from upturned floorboards, personal equipment, sustenance kits, and such. The flight deck had extra equipment all over it. In addition, the co-pilot had twisted off a fluorescent light rheostat switch when the plane hit the turbulence as he was adjusting it. The radar observer reported his camera had been knocked to the floor. After his experience in leaving the eye of Beverly at 1,500 feet, the lieutenant had one statement to make, and he said it could not be overemphasized. An airplane with human beings aboard should never be required to fly through the eye of a typhoon at an altitude below 10,000 feet. If a pattern must be flown at 1,500 feet in the storm area, it should be clearly indicated that the area of the eye be left at the 700 millibar level and the descent be made at a distance of not less than 70 miles from the center. Full use of radar equipment should be exercised in avoiding any doubtful areas. On inspection after landing, the following damage to the airplane was found: a bent vertical fin, warped flaps, tears in fairing joining the wing and fuselage, untold snapped rivets on all parts of the airplane, fuselage apparently twisted, and one unit in the center of the Bombay was torn from its mountings. Reports of this kind leave some doubt as to whether the typhoon actually is not more violent than the West Indian hurricane. Another typhoon of extraordinary violence, which gave the storm hunters serious trouble, struck Wake Island on September 16, 1952. Wake is a little island in the Pacific Ocean, a small dot on the map, the only stopping place between the Hawaiian Islands, more than 2,000 miles to the eastward, and the Marianas, more than 1,000 miles to the westward. This spot, a stop for Pan American planes, was captured by the Japanese and then recaptured by the United States in World War II. When the Korean War opened, military planes used this small island as a refueling place en route from the Pacific coast of the United States to Japan. Before taking off from Honolulu, the airmen wanted a forecast for this long route and a report of the weather at Wake. Also, before taking off from Wake, they asked for a forecast for the trip to the next stop at Guam, Manila, or Tokyo. The military called on the Weather Bureau and Civil Aeronautics Administration to furnish the weather service and the communications. They started operations at Wake very soon. By 1952, men from these two agencies were on the island, some with their wives and children. The Standard Oil Company and Pan American Airways also had people there. For the most part, they were housed in Quonset-type structures, but some old pillboxes constructed during the war still dotted the island and could be used for refuge from typhoons if the wind-driven seas did not rise high enough to flood them. There were only 3 concrete buildings, and they were used for offices and storage. On the morning of September 11, 1952, the Weather Bureau forecaster drew a low center on his weather chart far to the southeast of Wake. His analysis was based largely on 2 isolated ship reports, the only information available from a 1 million square mile ocean area lying to the east-southeast of his tiny island station. Here was just enough data to arouse suspicion and alarm that a developing tropical disturbance was somewhere, anywhere, within this vast expanse of sea and air, but not enough information to indicate a position, or probable intensity, or actually to confirm the existence of a well-defined storm. During the next 3 days, the question of continuing the low on successive charts and the problem of deciding its position were mostly matters of guesswork on the part of the Weather Bureau staff at Wake. There was only 1 ship report from the critical area during the time. Then, on September 14, the existence of a vortex was established. A single ship report, together with reports from Kwajalein and Eniwetok, gave good evidence of cyclonic circulation. From this time on, until the storm struck at daybreak on the 16th, everybody on the island worried about it, and the weathermen went all out in tracking it and disseminating information. Meanwhile, the typhoon, which had been named Olive, grew into the most destructive storm to hit Wake since it was first inhabited in 1935. The forecaster's job was a difficult one because of meager observational data. There were heartbreaking delays in securing airplane reconnaissance due to mechanical breakdown that grounded the B-29 stationed at Wake for that purpose until an engine part could be flown in from Tokyo. Early on the morning of the 16th, strong winds of the typhoon began to sweep across the island, a very rough sea was breaking on the shores, and debris was flying through the air. One can easily imagine the alarm of these people in the vast Pacific on a tiny island beginning to shrink as the waters rose, and giving up its soil, rocks, and parts of building to the various winds steadily increasing. A large power line fell across several Quonsets just north of the terminal building, and huge sparks began flying where they touched the Weather Bureau warehouse. The account which follows is condensed from the report made by the Weather Bureau man in charge, Walton Follansbee. The wind indicators in the weather station shorted out early, and expensive radio-zoned and solar radiation equipment was badly burned by the runaway power. The indicators in the tower, however, remained operative until the last weatherman abandoned it. They took turns climbing the tower steps to check the velocities, calling the readings off over the interphone from tower to weather station. On Follansbee's last trip to the tower, the strongest gusts observed were 82 miles per hour, although one of the observers had caught gusts to 90 miles per hour shortly before. The strain on the structure was severe, and he was happy to get down the stairs safely. Soon afterward, Jim Champion, observational supervisor, took full responsibility for this unwanted task. He then reported over the interphone that the wind was north-northwest at 80 miles per hour, with gusts to 110. Follansbee advised him to abandon the tower. He replied that he believed he was safer staying there than trying to come down the stairs, which were wide open to the elements. He was told to use his own judgment, since it was his life at stake. Women and children had been taken to the terminal building or other safe places than the Quonsets, which now began to break up. Anybody who ventured in the open was likely to be blown off his feet, and that was exceedingly dangerous, for the sea was close by, and now and then the roof of a Quonset went off and was carried dangerously across the island and out to sea. Winds of hurricane force blew the water from the lagoon, which began engulfing the south and east parts of the island. The wind reached a steady velocity of 120 miles an hour, with gusts up to 142 at the height of the storm. By that time, most of the women and children were huddled in the operations building, and they were terrified when the roof went off, leaving them exposed to the torrential rain and furious winds, but the walls held. About this time a report was received from a reconnaissance plane that had come from Guam and made its way into the center of the typhoon. The crew put the center about 35 miles northeast of Wake, but said the plane was suffering structural damage and was heading for Kwajalein. By evening the winds were subsiding, and a check showed that owing to such preparations as they had been able to make, and the constant struggle of all on the island to prevent disaster, not a single life was lost, and no one was seriously injured. Wake Island, however, was a shambles, and there was very little food, not contaminated, and practically no drinking water. The water distillation plant had been destroyed. But soon one of the Air Force B-29 planes, ordinarily used in typhoon reconnaissance, flew in from Kwajalein and brought 300 gallons of water in GI cans lashed to the bomb bays, and 2 tons of rations for distribution to the battered and hungry people of Wake Island. Before long, the little island was back in business, serving the big planes on the way from Hawaii to the Far East. End of chapter 12.